All right. But now what happens if this isn't a compound? How do I name that? Well, first step, we name the cation using the element's name and the Roman numeral to indicate its charge. Typically, all the transition metals will be a cation. There are a couple that can be anions, but at that point in time, it will be indicated which charge it has. So after you name the cation with its Roman numeral, you then are going to name the anion using the root name and adding IDE and put it all together. Let's do some practice. So PT, that stands for platinum. Cl, that's chlorine. How we indicate what charge it is by looking at the anion, figuring out how many atoms it has. So chlorine has 4 atoms. And looking on the periodic table, we know typically all the halogens have a -1. So that means if chlorine is a -1 charge, we're going to times that by -1. So that means that the overall charge of chlorine is a -4. So we have to balance that out with platinum being a +4. So let's write the name out. Platinum, remember we use the elemental name for the cation. So we're going to write platinum. Then use a Roman numeral to indicate its charge. And we're going to put that in parentheses since there's a name after it. And then we're going to name the anion, taking off the ending and putting IDE. So chlorine is going to become chloride. Let's try the next one. The next one we have titanium and sulfur. You notice sulfur has a 3 there, and titanium has a 2. So sulfur's typical charge, it's in the group 16. Typically these have a -2 charge. They gain 2 electrons, so its typical charge is -2. So if we take -2 times 3, we get an overall charge of -6. But this isn't a -6 because it's got 2 atoms there. So if we take -6 divided by 2, we get 3. So titanium's overall charge is a +3. So we're going to write it like this. Remember, cation, we use the elemental name first. So titanium, we use Roman numerals to indicate the charge, which is 3. Sulfur, we're going to take off the UR and add IDE, and it's going to be sulfide. So this is titanium 3 sulfide. Let's try the next one. PD, that stands for palladium, and I is iodine. If you look at where iodine is located on the periodic table, it's group 17. That means typically it's going to have a -1 charge, and we have 2 atoms there, so we're going to take 2 times 1, which gives us an overall charge of -2. Palladium doesn't have any extra atoms there, so that means to balance the -2 charge out, it's got to have a +2 charge. So naming the cation, we're going to use the elemental name, which is palladium. Indicate the charge using Roman numerals, which is a +2 in this case. Naming the ending, taking the root name and adding IDE, so this overall is going to be palladium 2 iodide. Let's try the last one. Zn, that stands for zinc. Po, that is polonium. You notice that there are no extra atoms here, so the charge of polonium is going to be equal to the charge of zinc. Polonium's typical charge is -2 because it is in group 16. So that means zinc must have a positive 2 charge. Naming the cation, we're going to write zinc, indicating its charge with a Roman numeral. It's going to be 2. In polonium, we're going to name poloniide. So this is zinc 2 poloniide. All right. Now I'm going to throw another thing at you. What if I had this thing called a polyatomic ion? These are ions that are formed from more than one atom. If you take a look at the picture here on the right, I have some typical polyatomic ions there for you. And some of them are cations, some are anions. I have also given you a polyatomic ion chart in the modules that will be helpful to either print off or keep somewhere in a file so that you always have access to it. So basically, to name the polyatomic ions, we just use the name that is given to them already, and you can find that on the chart. So some examples, I've got SO4 2-. We call this sulfate. There's NO3-. This is nitrate. But then if you look over, I have SO3 2-. Notice there's a difference in the number of oxygens there. So we changed the name from sulfate to sulfite. Same thing with NO2. We have a different number of oxygens. Charge stays the same. Instead of calling it nitrate, this is now nitrite. Let's try naming. Taking a look at your polyatomic ion chart, you will notice that CN-'s name is cyanide. So that is the name of that ion. Let's try PO4 3-. On your polyatomic ion chart, you will have columns for specific charges like +1, -1, -2, and -3. So we're going to go look at the -3 because that's the charge that we have indicated here, and we're going to try and find PO4 on there. Well, looks like the name of this one is phosphate. Let's try ClO3-. So we're going to look in the -1s because the charge is -1. Look for ClO3, and you should find that its name is chlorate. MnO4-, again, looking in the -1s there. Look down until you find MnO4, and the name of that one is permanganate. It's permanganate. All right, that seems simple, looking at a chart, writing down the name. But what if they were in a compound? We're going to take the first step, name the cation, just like we have always done, either using the element's name or the Roman numeral to indicate the charge if we need to. Then name the polyatomic ion using the ion's name and putting it all together. Let's do some practice. We've got BaCN2. So Ba, that stands for barium. That's your cation. So we're going to write barium. And you notice that Ba is in column 2. So that means it's typically going to have a +2 charge. So this Cn has 2 atoms. So it needs to have a negative charge that multiplying it by 2 will give it a -2. And typically that is going to be a -1. So let's find Cn-. And it looks like that's cyanide. So it's going to be barium cyanide. Let's try the next one. We've got potassium, PO4. Potassium, that's your cation, so we're going to name that. It's in the first column, which means the charge is going to be typically a +1. So we have 3 atoms here. And PO4, this is your polyatomic ion. So if we have 3 atoms of potassium, and it typically has a +1 charge, there's no extra atoms of PO4. Let's take 3 times, well, that gives us a 3. So that must mean with no extra atoms of PO4, the charge of PO4 should be -3. Looking on your chart, you notice, yep, there's a PO4 -3, and its name is phosphate. All right, let's try the next one. We've got CaClO3 2. Ca, well, that's calcium, and that's your cation. ClO3, if you look on your chart, you can find ClO3 that has a -1 charge, and the name of that is chlorate. So typically there are 2 ways to do this. You can look at the polyatomic ion and see if you can find it on the chart, or you can figure out its charge first and then look in that charge's location. Either way works, it just depends on which method you prefer. The first 2 we did, finding the charge first. The next 2, just like the last one, we're just going to look on the chart and figure out where it is just by looking at its symbol. So this one we have Al2SO43. So Al, well, that stands for aluminum, and that's my cation. So I'm just going to use its element's name. SO4, let's see if we can find that on the periodic table or on my polyatomic ion chart. Yep, I can. It's in the -2 column. And that means its name is sulfate. Awesome.